Okay, so we're going to look at the graphs of y equals sin x first, and then we'll do cos x, and then we'll do tan x. Um, okay, so just out of interest, whenever I go through these lessons, do you take notes as well, or are you just watching? Okay, good. Okay, well, this one might be a little bit difficult to take notes just because it involves some drawing. But little sketches if you want. Like I said, I'm recording this so you can go back and watch it as well, okay? So this is our graph of y equals sine x. Um, what units am I using? Yep, I'm using radians. Um, how many, this is 2 pi radians, so how many degrees would this be? Yeah, 360, okay, so we're remembering that pi radians is 180, so 2 pi radians is 360, so this is 360 degrees. This would be how many degrees? 180. Jesse, how many degrees would this one be? Pi over 2. So we've got, what's, how many degrees is pi again? No, no, no. So how many degrees is pi? Oh, so 2 pi is 360. Right, so 1 pi is 180. So pi over 2 is, no, pi over 2? 90, okay. Can you see the screen okay, Jesse? Okay, are you on a phone? Are you said you were on a phone last time, did you? Okay. Okay, good. All right. I will show you the graph in degrees as well, but let's have a, if I zoom out a bit, what can you tell me about this? What can you tell me about the sine curve? Any interesting points? Anything at all about sine? Well, what do you notice about the shape of it? Yeah. Yep. Yeah. 180, 360. Yeah. Right, okay. So, like, what's a really simple way of saying that? What is it? What is this sine curve doing? It's doing it every 360 degrees. Yeah, it's got a full, not yeah. Yeah, it's the way I would say it is it's repeating every 360 degrees. It's repeating. It's starting again and doing exactly the same thing. Okay, so every 360 degrees or pi or 2 pi, sorry, radians, it is repeating. How high does it go? What's the maximum of the sine curve? Yep. And what's the minimum? -1. Okay, it goes as high as 1 and it goes as low as -1. I'm just going to copy this and put this into our, okay, there we go. Okay, so I'm going to write down here that y equals sine x repeats every 360 degrees or every 2 pi radians. Okay, its maximum y value is 1 and its minimum y value is -1. And I also want to, sorry, let me just, that's really annoying. Okay, so we're also going to say, so this whole thing about it repeating every 360 degrees, this is called the period. Okay, so that's when it repeats. So the period is 360 degrees or 2 pi. Okay, so every 360 degrees or 2 pi it repeats, and that's called the period. What can you tell me? Actually, so let's create a little table. I want 3, and I want to go 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and in my table, I'm going to put x. I'm going to put, and this is in degrees, I'm going to do x radians, and we're going to do y equals sine of x. So some of these you know already. Start off with 0 degrees, then we're going to look at 30 degrees, 45 degrees, 60 degrees, 90, 180, 270. I did that well, didn't I? And then 360. Okay. So 0 degrees. How many radians is 0 degrees? 0. 30 degrees is how many radians, Darius? Pi over what? No. So 30 degrees is how many radians? Yeah, pi over 6. Good, because remember, pi is 180. 180 divided by 6 is 30. Somebody else from standard, 45 degrees is how many radians? Pi over 4. 60 degrees, somebody else from standard? 3. 90 degrees, Ari? 90 degrees in radians? Pi over 2. 180 divided by 2 is 90. 180 degrees is just pi. What about 270 degrees? Good, 3 pi over 2. Okay, if we think of it, what do I do to 90 to get up to 270? I multiply it by 3. And 360 is 2 pi. Okay, so what is, looking at our curve, sine of 0 degrees, or sine of 0 radians? Zero. We can all see the screen, can't we? Are you sure? Okay. How about somebody give me another one of these? Sine of one of these values. And you can pick them off by using the curve. There's some of them are easier than others. Yep, sine of 45 is No, 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 no. 45 degrees is pi over 4, remember, okay? 45 degrees is pi over 4. We're working out what sine of these values are. And it's the same thing because they're essentially the same value. So what's sine of 45 degrees? Yes, it is. What is that going to give you? Yep. It would be 1 over root 2. Okay, so sine of pi over 4 is 1 over root 2. Somebody give me another one of these. Sine of one of these values. What's sine of 60? Good. Square root of 3 over 2. Some of these are easier than others. We're picking the hard ones first because we can look at the graph and pick out, well, these ones are nice and straightforward now. Sine of 90 is 1. Okay, there's 90. Okay, sine of 90 is 1. Sine of 30 is 1/2. Good. Good. Sine of 180, there's 180, it's 0. Sine of 360 is 0. Move this out of the way. How do I move that? Oh, there we go. And what about 270? It's -1, okay? There is my 3 pi over 2, or 270, okay? So these are values that you need to know, okay? And we know the 30, 45, 60 easy enough, but the other ones as well you have to be aware of. Now just to go back to, I'm going to put this one up again, but I'm going to show it in terms of degrees. I know that you're not used to using radians, but it is something that we have to get used to. Okay, and I don't want it in going up by. Okay, so there is, let me zoom out a little bit. I've got in tens actually. Come on, zoom out. Sorry, I want to show this a bit nicer. 370. I'm going up in groups of 10. Okay, that'll be. All right, so here is the same graph. This time we are looking at it in terms of, this time, in terms of degrees. I'm going to move it, put it underneath this one. Okay, so it's exactly the same thing. This time it is in degrees, okay? So I can see there's my 360. 180 is smack bang in the middle. 90 degrees. Sine of 90 gives me a value of 1. And sine of 270 gives me a value of -1. Okay, so you have to be able to visualize both of these. They are essentially the same thing, except one of them is in degrees, one of them is in radians. Okay. Let me ask the question. What can you tell me about the value of, say, sine? What's this 40? The value of sine 40. There's 40, and the value of sine. That's 180. value of sine 140. What can you tell me about those two values? Yeah, they're going to give me the same value out, yeah. If I look at it, these two values are going to give me exactly the same value out. Okay, now how many degrees is 40 away from 0? Yep, and how many degrees is 140 away from 180? Yeah, so what I'm saying here is sine of 40 degrees is exactly the same as sine 140 degrees. What would sine of 30 degrees be the same as? Yeah, 150 degrees, because yeah, well, yeah, right, yes. If this one is 30 degrees is 30 degrees away from 0, I can see here. And because the shape of the sine curve is symmetrical, okay, between 0 and 180, if I go 30 degrees back from 180, that brings me to 150. I can see that these two values are going to give me the same thing out. So if I was going to put this in terms of variables, sine of x is going to be the same as sine of what? What am I doing to this to get this number? What am I doing to this to get this number? What am I subtracting 30 off of to get 150? What am I subtracting 40 off of to get 140? I'm subtracting it from 180, so what's going to go in the bracket here? Yeah, 180 minus x. Good. Now, if you're using, so this is degrees, if you're using radians, yeah, it would be pi minus x. Now, we'll deal with degrees to kind of keep us on the straight and narrow for now. But this tells us, okay, and this is the kind of really important thing, that if I'm trying to work out the value of sine 150 in a non-calculator paper, okay, well, I think to myself, sine 150 is going to be the same as sine 180 minus 150, which is just sine of 30. And what's sine of 30? Yeah, sine of 30. We know from our triangles. Oh, no, 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 no. Sine of 30 is 1/2. So sine of 150 is just 1/2. Sorry. What just happened? Undo. Oh no, lost everything. This is amazing. Okay, there we go. So sine of 150 is 1/2. And this is really, like I said, really important for non-calculator papers. And they may give you something like, okay, sine of 120 degrees. Sine of 120 degrees is going to be the same as sine of what? Okay. And does somebody else want to explain why? Yeah, well, the 180 is 60 away from 180. So, yep, this one has to be 60 away from 0. Yes, Jesse, good. And what do I know? What's sine of 60 then? Sine of 60 is 3 pi over 2. So sine of 120 is 3 over 2. So 3 over. Does that kind of make sense? It's a little bit, it's kind of a strange thing to kind of get your head around. But how are we finding it? No, we don't. So, all right, so if it's a non-calculator paper, they're going to give you ones that you will be able to work out the exact value, okay? So things like this, sine of 150, sine of 120. If it's something like this, it will be on a calculator paper, and you can just use your calculator, which makes things a lot easier. Okay, good question. Okay, here's a question for you. What is... I want everybody to type your answer into the chat. Okay. What is sine of? Think about looking at the curve. Sine of 300 degrees. Okay, use this curve to kind of help. This value here is 270. No, it's not. That's 180. What am I talking about? Sorry, that's 180. 250, 260, there is 270. I want, what's the value of sine of 300? Ooh, I'm getting answers in. I've got one answer so far. Just in the chat and Zoom. Okay, I've got one answer. Do you need a helping hand? Okay. So, think about, is your answer going to be positive or negative? Okay. It's going to be negative because there's 300. It's going to give me a value out that's going to be negative. Okay. Somebody else, apart from somebody in the standard level, 300 degrees is how far away from 360? 60. Okay. So this value here, oh, I'm running out of time. This value, sine of 300, is going to be the same as what on this side? Thinking about 240, right? Who said that? Good man, Tyler. Okay, because it is 60 away from here. Okay, so sine of 300 is the same as sine of 240. Okay, because these are going to give me exactly the same value out. Now, sine of 240 is how many away from 180? 60, okay. Somebody from SL, apart from Tyler. Thank you, Tyler, though. If it's 60 away from 180, if 240 is 60 away from 180, what value is 60 away from 180 in the opposite direction? 120, right. But what does this give me out? It gives me out a positive or negative answer. Positive, okay. but it's going to be exactly the same distance from 0, okay, as this one. This is going to be exactly the same distance because of the shape of this curve. So I can say that sine of 240 is the same as negative sine of 120. Okay? You with me? No? Okay. um, are you okay with the 240 bit? You sure? So 300, sine of 300 is the same as sine of 240. Okay? If I go out in the other direction from 180, okay, I can see that these distances, if I go out an equal amount, are going to give me exactly the same values out, except one's going to be a positive value and the other's going to be a negative value. Because it's got rotational symmetry, this curve around 180 degrees. That value is going to give me the same as that value. Yes, no? Kind of. Okay, well, we'll have another look. To finish it off though, sine 120 is the same as sine 60. And we know that sine 60 is, okay, that's correct. And we're going to have the negative value because it is negative. So our answer is negative root 3 over 2. Okay, I kind of picked a nice hard one there to kind of test you on, so I apologize. Sine 300 is the same as sine 240, which is the same as negative sine 120, which is the same as negative sine of 60. Okay, now unfortunately, that's the kind of process you need to go through if you have to work something out like this in a non-calculator paper, but we will practice it, okay? We will practice. Yep. Yeah. Yes. Yep. Yeah. Yeah, that's a good point. Like Jaden said, like, and I know I'm drawing all over this, which isn't helping, but the bottom half of this curve is, if I think about it, it's exactly the same as if it was flipped. Okay, it's symmetrical, and so you can think of it in terms of, okay, well, what would it be if it was this way up, okay, and then shifted back. Um, but we will practice these, okay? But unfortunately, we look at the cos graphs and the tan graphs, but we'll practice the sine ones first just to kind of make sure that we're all on the same page with them. Any questions? I'm going to stop sharing for a second. I'm going to stop recording.